Alright, we're ready to do the last of the conics. So we've covered circles and parabolas and ellipses, and now we're going to do hyperbolas. So let's jump right into the definition. A hyperbola is a set of all points. Remember, everything we've been defining has been a set of points with specific characteristics. So it's a set of all points in a plane, the difference of whose distance is from two distinct fixed points, called the foci, is a positive constant. So if you remember for ellipses, it was the sum of the distances. And so now for hyperbolas, it's the difference of those distances. So let's take a look at what our picture is. And this is going to be a pretty complicated picture. So it's really, really important that you go through and make sure you familiarize yourself with all the names of how we label everything. So the actual hyperbola kind of looks like two pieces of an ellipse. Let me trace over this. The actual hyperbola is this part right here. And it goes on forever and ever in those directions. And then this piece over here. So it's kind of like two sections of an ellipse, except they're flipped going in the opposite direction. Alright, so but we need some of this other stuff in our picture to help us, and you'll understand what all that other stuff is in this lesson. Alright, so the first thing we need to know is where, well, let's start with the center is our red dot, and the distance from the center to the vertex, and these are our vertices, the blue dots. The distance from the center to that is A, just like it was before for an ellipse. So from the center to a vertex, that is A. Now the distance from the center to a focus, and there are foci right there in green, the distance from the center to a focus is C. Now notice for the hyperbolas, C is actually bigger than A, because the focus is further away from the center than the vertices are. So this is going to change some things for us. But that's probably one of the key things to remember. The difference between a hyperbola and an ellipse is that C is bigger than A for the hyperbola. It's smaller than A for the ellipse. And then we have, there's your center. And then we have this other value B, which is not showing up here. So I'll put it in. And B is the distance here from the center there or from the center down to there. Now, we don't have a major and a minor axis for a hyperbola. We have different names for them. We have the transverse axis, which is like the major axis, and the conjugate axis, which is like the minor axis. Okay. So as I mentioned, the distance from the center to a vertex is A. The distance from the center to the focus is C. And the distance from the center to the endpoint of the conjugate axis is B. And that's what I drew in purple in the picture. Now, we have a different, well, you can think of it as a Pythagorean relationship. We have A squared plus B squared equals C squared. If you remember for the ellipse, it was B squared plus C squared equals A squared, because A was the biggest value. A was the farthest distance. It was from the center all the way to the vertex, either vertex, and that was bigger than C. But here C is bigger than A, so we're just flipping the C and the A in that equation. So now it's A squared plus B squared equals C squared. The other important point to notice is for a hyperbola, the length or the distance that A represents might be smaller than B. For the ellipse, it was always the major axis was bigger than the minor axis. But that's not the case here. So A could be smaller than B. Eccentricity is still defined as C over A. But remember now, since C is bigger, the distance from the center to the focus is longer than the distance from the center to a vertex. Now our eccentricity will be greater than 1. So when it was 0, we had a circle. And then between 0 and 1, we had an ellipse. Greater than 1 is a hyperbola. And instead of a major axis, we have a transverse axis, so that has length 2a. And instead of a minor axis, we have a conjugate axis, and that has length 2b. So it might be worthwhile to pause for a minute now and go back and look at the picture and how everything is labeled and make sure that you understand the terminology. Okay, so now we're ready to look at our equations, and we have two orientations, just like we did for an ellipse. So the first one is when the hyperbola is opening to the left and to the right, which means our transverse axis, let me draw that in there, the transverse axis is horizontal. And in that case, the x term is going to go first, the y term is going to go second, and it matters because we're subtracting instead of adding. With an ellipse it was a plus, so actually we could flip them and it didn't matter. But for the hyperbola, it's a minus. So when it's opening to the left and to the right, the x squared term goes first, and then it's minus the y squared term. Now the other difference is the a, the transverse axis, will always be the first denominator. So we're never going to switch these. So a always goes first, b always goes in the second fraction. So even when we take our other orientation, where it's opening upward and downward, so now our transverse axis is vertical. Now the y term goes first, and then minus, and then the x term. And notice we still have a squared in the denominator of the first fraction and b squared in the denominator of the second fraction. Alright, so those are some of the important things to know about the two different equations. So when we're trying to come up with an equation, the first thing you have to decide is which orientation are we dealing with, and that'll tell us how to set it up. And as I mentioned a little while ago, that value of a is not necessarily greater than b. So let's go through, I think I have 3 examples here. Let's go through a few examples. Write the standard form of the hyperbola with foci -6, 2 and 4, 2, and vertices at -4, 2 and +2, 2. And then we want to graph it and find the equations of the asymptotes. So I'll explain how those are going to be useful as we work through this. Okay, so first let's start with the vertices. Let me plot those. -4, 2, that's right here, and +2, 2, right there. Alright, so right away you know that the transverse axis is horizontal. So our equation is going to look like this. X minus h quantity squared over a squared minus y minus k squared over b squared equals 1. Alright, so let's see where the center is at. Well, that's halfway between these 2 points. You could use your midpoint formula, or you could just count. But there's the center. The center is at -1, 2. So it's going to be x minus a -1, x plus 1 squared, and then y minus 2 quantity squared. So let's see, what was A? A was the distance from the center to a vertex. Well, we have that right now just looking at our picture. So if we count, that's 3 units, so 3 squared or 9. We need to figure out B, but we do know where the foci are at, so let's plot those. -6, 2, and 4, 2. There's your foci. Now, here I'm just going to draw a rough sketch, but right now we're looking at something like this. So that's what our hyperbola is going to look like. Alright, C was the distance from the center to a focus. So you can see in the picture here, that has a length of 5. So C is 5. See if I can find some room for this. Let's do it over here in the corner. So C is equal to 5. A was equal to 3. And we know that A squared plus B squared equals C squared. Well, this is a nice Pythagorean triple. So you probably already figured out that B is going to equal 4. So therefore we can complete our equation. And notice B is bigger than A in this case. So you have to forget about what you were doing with the ellipses, that A was always bigger than B. Okay. So now, where do we go from here? Well, I'm not sure if I drew my parabola correctly or not. Maybe it should be curved more or less. I don't know. So how do we figure that out? So the next thing we need to do is we need to make a box. And the box, as you saw in my picture on the previous page, is going to tell us exactly where to draw asymptotes, and then we know how to graph the shape of our hyperbola. So we already have the width of the box. It goes from one vertex to the other. So it's 2a, the length of the transverse axis. And then we need to make the other dimension for the box. In this case, it's going to be vertical, and that needs to be 2b. So that means we're going up 4 units there and down 4 units there. So the box that we're going to make has dimensions 2a by 2b. There we go. And so now the asymptotes, I'm going to move this up, the asymptotes are going to be the diagonals of this box, and we're just going to keep them going, and they go through the center. So there's one. I could have been a little more accurate, I guess, with the line tool. There's 2. Close enough. All right, so that tells us the shape of our hyperbola, and so now I'm ready to actually graph the hyperbola. So what I'm going to do is I'm just going to go up, and it's going to get closer and closer and closer to those asymptotes. And now I've got a pretty accurate picture of what the hyperbola looks like. And that would be in blue. Okay, so let's see. I have graphed it, check. I need the equations of the asymptotes. Let me scroll back up. It said write the standard form of the hyperbola, so I have that right here. If you want to go ahead and write 9 and 16 for your denominators, that's fine. So now I just need the equation of the asymptotes. So now what I want you to do is realize they go through the center. So, the book does it a little differently. I like to use point-slope form for the lines. And later on in calculus, you'll use point-slope form a lot more than you will slope-intercept form. So first of all, we need to know that both these lines go through the point -1, 2. All right. And then we can figure out the slope of the lines, because let's take the one with the positive slope. If I start at that center point, how many do I go up and how many do I go over? Well, how many I went up, that's the B value, and how many I went over, that's the A value. Don't always think it's B over A, because if our orientation shifts, then it's going to be A over B. So, don't try and memorize, oh, it's always this. Think through it. As long as you have a conceptual understanding, you should be able to get the solution. All right, so the slope in this case is going to be +4, +3. So the slope is 4/3. What about the slope for the other one? That's going to be up 4 and 3 to the left. So that's actually going to be -4/3. Call that slope 1 and slope 2. Both of them go through the point 1, 2. So for the equation of the asymptotes, let's use point-slope form. So y minus 2 equals the slope, so plus or minus 4/3. I'm actually going to write it as one equation which represents both of the asymptotes, x minus a negative 1, so x plus 1. Now that's not the form that your book will have answers in most of the time, but you can rearrange that to compare with slope-intercept form. And that's a nice easy way to write the equations of your asymptotes instead of doing them separately and then you're going to have two totally different linear equations. Okay, let's look at another one. Find the center, the vertices, the foci, the length of the transverse axis, the length of the converse axis, equations of the asymptotes for this hyperbola, and then graph it. That might seem a little intimidating, but it really isn't that bad. So here's what we're going to do. First of all, we're given the equation and we have to find out all the information. We need to know A and B and C so we can figure out where the center and the vertices and the foci are at, and we can get the slope of the asymptotes, and then we can write the equations of those. So it all starts with dealing with this equation. Now, that's not in the standard form, but we dealt with this with circles and with ellipses. So what we need to do is put it in the right form. So we're going to have to complete the square. So let's take our x terms. We need to factor out the leading coefficient. So we'll have 4 times the quantity x squared plus 2x, if I factor 4 out of the 8x. And then minus 3, and we have y squared. Notice there's no y to the first power. So I'm just going to leave it like that. And then let's move the 16 to the other side. So now to complete the square, this would need to be, take 2 divided by 1, 2 divided by 2 is 1, and then square it. So this is going to need to be a plus 1. We don't have to complete the square for the y term, because there's no y to the first power. So now we have what we need. We've got 4 times x plus 1 quantity squared minus 3 times y squared. If you want to write it like that. Here, this might even make it a little more helpful for you to see. What if we said y minus 0 squared equals negative 16? Now, I almost forgot 4 times, I really added 4 to the left side, so I need to add 4 to the right side as well. So that's going to give me a negative, oops, switch to red. That's going to give me a negative 12. Now I know you might be thinking, wait a minute, it's supposed to be a positive 1. Well, that's fine. Let's divide both sides by negative 12. And I'll divide each of these separately. So now I'm going to get x plus 1 quantity squared over negative 3 plus y minus 0 squared over positive 4 equals 1. Now that's pretty close. Notice we're supposed to have something squared minus something squared. So let's just put it in reverse order. So we got y squared over 4 minus x plus 1 squared over 3 equals 1. Now we've put it in standard form. And so we know the center is at negative 1 comma 0. We know a squared is equal to 4, so a is equal to 2. We know b squared is equal to 3, so b is equal to the square root of 3. And then we can find c, because a squared plus b squared equals c squared, so c is equal to the square root of 7. Alright, so I've got almost everything I need. Now, the orientation has y squared first, which means it's opening upward and downward. The center is at negative 1, 0. Right there. The transverse axis goes from vertex to vertex. Since we know it's opening this way, that means that my transverse axis is vertical. So the A is equal to 2, that tells me 2 this way and 2 this way will take me to the vertices. So there's your vertices. So let's keep colored. So let's say here, vertices are at -1, 2, and -1, -2. And we've listed the center. So we've got the center right there. We've got our vertices. Now I just drew those quickly. We'll fix those later. All right, what else do we know? We know b. B is the square root of 3, which is a little bit more than 1. So I know that my box is going to look something like this. And when you get square roots for a or b, you just have to kind of eyeball it a little bit. So I know the, welcome back to that. Well, let's go ahead and list that. I want to go through and check off everything that we have here. Find the center, check. Find the vertices, check. We have to find the foci, we'll do that in a minute. Find the length of the transverse axis. Well, that's going to be 2a. And the length of the converse axis, that's going to be 2b. So let's write those in here. Transverse axis is 2 times a, so that's going to have a length of 4. And the conjugate axis, that's going to be 2 times b, so 2 times the square root of 3. Alright, so we've checked all those off. So, got that one, got that one. We need the equations of the asymptotes, and we need the foci. Alright, so we figured out what c is. C is the square root of 7, and we know the square root of 7 is 2 point something. So what you could do, if you wanted to be a little more exact, it's a little more than 2.5. So for our foci, we have to go 2.5 up and down from the center. So 2.6-ish. It's going to be right there and right there. So what are those coordinates? So our foci are going to be, well, it's -1, comma, and then it went up the square root of 7. And then the other one was -1, and then we went down the square root of 7. If you want to write that as one answer and just say -1, comma, plus or minus root 7, that's fine. Same for the vertices, -1, comma, plus or minus 2. Usually it doesn't work out that way, but in this case it did because we were on the x-axis. Okay, so now we need the equations of the asymptotes. So we know they both go through the center, which is at -1, 0, so that's a point. And then we need the slopes. Well, the first one going here, and then the second one. Note to self, use lines next time. Alright, so what's the slope? The slope is going to be up the distance to the vertex, so up A and over B. Remember in the other example it was up B and over A? Well, that's because the orientation was different. So this time it's A over B for the slope, and then A over -b. So the slope is going to be A over B, and the second slope is going to be the opposite of A over B. Now if you want to rationalize that, that's fine. And actually at this point, if you don't rationalize, I wouldn't take off for that. I forget what they do in the book. For the answers, they probably rationalize. So now we can write the equations of the asymptotes using the point slope form. So y minus 0 equals plus or minus 2 root 3 over 3 times x minus a -1, so x plus 1. If you don't write y minus 0, that's fine. So let's go back and make sure that we've checked off everything. We've got the center, the vertices, we got the foci, we have the equations of the asymptotes, and now we just need to graph. So, since we have our box and our asymptotes, we're ready to draw our graph. Sometimes people like to draw the asymptotes with dashed lines, so it's not as overwhelming when you're looking at the graph. But that's it. Alright, I have one last example. Find the equation of the hyperbola with vertices at 0, -5 and 4, -5, and they give you the equations of the asymptotes. So you're going to see that as long as you're given some information, it should be enough to figure out all the other stuff. So I don't even have a graph here, I'm just going to go ahead and plot this very quickly. So the vertices are at 0, -5, that's down here, and at 4, -5, which is over here. So right away, I know the orientation. I know that it's opening this way and this way. So that means that my transverse axis is horizontal. So I know the equation is going to look like x minus h squared over a squared minus y minus k squared over b squared equals 1. And let's see, where's the center? The center is halfway between, so that's going to be at 2, -5. So I know my h and k, so x minus 2 squared minus y minus a -5, so y plus 5 squared, equals 1. Now a is the distance from the center to a vertex, so a is equal to 2. So this is going to be 2 squared or 4. Now, what else? If you notice for the equations of the asymptotes, this tells me the center. The center is at 2, -5, which we figured out already. But the slope is 5/2. And notice from this picture, that means that I go up 5 and over 2, and that's going to be the slope of one of my asymptotes. So 2 here, 5 here. So it's b over a in this case. Now, what if a wasn't 2? What if a was, let's say, 1? I want you to realize, and this usually doesn't come up a lot, but it can, so don't be thrown. But this 5/2 doesn't mean b is 5, a is 2. It means the ratio of b over a equals 5/2. So in this case we got lucky. A was equal to 2, so we know b is equal to 5. And 5 squared is 25. And that's it. Okay, so I have some problems here for you. Once again, if you have any questions as you work through these, please shoot me an email and I'll get back to you as quickly as I can. But hopefully this is going well for you and you're checking your answers as you go. And this is the only assignment I'm going to give you this week because it's going to take you a while. So take your time, work through it, make sure you understand it.